Okay. Cool. All right, this is day 3. Ooh, hello. Cool. This is day 3. Whoa. I don't know if I like this. I can see myself. Yeah, no, this is not what I want. What the heck? Okay. This is day 3. I'm starting this early in the day. Because it's really late. And I keep getting tired and I can't focus. Either way, we're going to start where we left off. Finishing up these NumPy problems. I shouldn't put these off last, but off the video. But I wanted to at least commit to it. Okay. Honestly, I think he said some, I don't think this is important. So let me keep pushing. He said if it actually comes to a point where I need to know it, I'm just come back and look at it. Otherwise, I'm going to keep pushing just for the sake of progress. Because I'm not trying to get stuck in the same place for too long. Okay, so we're iterating pandas. So, yeah, we want Mars intro.
Congratulations on completing the NumPy section of this course.
Ooh, a little fast.
Coming up next is the Pandas library section. Pandas is one of my favorite tools, and it's a powerful resource for you as a data scientist. Let's go ahead.
Whoa. Oh, my mic is weird. Here we go. Test. Hello. Testing mic. Okay. Test that you guys can hear the video.
Go ahead and get started, and I'll see you at the next lecture.
Cool.
Hello and welcome to the Introduction to Pandas lecture. In this lecture, we're going to briefly discuss what Pandas is, how to get it installed onto your computer, and what to expect throughout this section of the course. Pandas is an open source library that's built on top of NumPy, which is why we learned about NumPy first. Pandas allows for fast analysis and data cleaning and preparation. A lot of people like to call Pandas Python's version of Excel, or if you're familiar with R, Python's version of R data frames. Python and Pandas really excels in performance and productivity for the user. Pandas also has built-in data visualization features, which we'll learn about once we get to Python for data visualization. Pandas can also work with data from a wide variety of sources. You'll need to install pandas by going to your command line or terminal, and then use either conda install pandas if you have the Anaconda distribution of Python, or if you install Python through a different method, you can also use pip install pandas. Either one should work for you. As far as what to expect throughout this section of the course, we'll first discuss series and how they interact with pandas. Then we'll build on top of that to go to data frames with pandas. Then we'll discuss some particular topics, such as working with missing data, how to use group by with pandas, merging, joining, and concatenating data frames with pandas, various pandas operations, and then how to get data in and out of pandas for a wide variety of formats, such as CSV files, Excel files, SQL, and more. Alright, let's go ahead and get started with pandas. Thanks, and I'll see you at the next lecture. Is just strings. So, a series can actually hold pretty much Hello everyone, and welcome to the series lecture. Series are going to be the first main data type that we'll be working with pandas, and then we'll build off of series to work with data frames in the next lecture. Let's go ahead and get started by jumping to the Jupyter Notebook. Alright, here I am at the Jupyter Notebook. A series is very similar to a NumPy array. In fact, it's actually built on top of a NumPy array object, but what differentiates the NumPy array from a pandas series is that a series can have axis labels, meaning it can be indexed by a label. Let's go ahead and say import NumPy as NP, and then I will import pandas as PD. And what we're going to start off with is creating various series from various object types. I'm going to make 4 Python objects. I'll create a list called labels, and this will just be 3 letters or 3 strings in a list, A, B, and C. Then I'm going to go ahead and make a list called my_data, and I will say it's 10, 20, 30. Then I will create an object called ARR, and this will be a NumPy array, and I'll just pass in my data. So one is a Python list, and another is a NumPy array. And then finally, as a dictionary, I will pass in A as a key, 10 as a value, B as a key, 20 as a value, and then C as a key, and 30 as a value. And that means I have 4 separate Python objects. I have labels, my list, and then I have my data, I have my array, and then finally I have my dictionary. Okay, let's show you how you can create a series and what it actually looks like. You can say pd.series, and note here I'm not actually saving the series to any variable name, I'm just using pd.series, but if you do shift tab here, you'll notice PD series takes a wide variety of parameters. We're just going to focus right now on the data and the index, which are the most important ones. First off, we'll just pass in data, and we'll set that equal to my_data. We'll just pass in that list. And note here, I get my series back. And it looks a lot like a NumPy array, except here it's very distinguished that we have an index, 0, 1, 2, and then the actual data, 10, 20, 30. And the key to a pandas series is that you can actually specify what you want that index to be. For instance, I'm going to go ahead and say pd.series. I will pass in data equal to my data, and then I will specify that the index is equal to labels. And remember that's A, B, and C up here. So when I run this, now I have a labeled index series. So I have A as the label for the index, and then 10 as the actual data point for that index. So unlike a NumPy array, I actually have index that are labeled, meaning I can call these data points using this labeled index. And just as a quick note, since data and index are actually in order as far as placing them in as parameters, you don't have to say data equals or index equals. You could just say my data and then labels as such. And you would also get out a series in the same manner. So you don't need to constantly specify data equals or index equals, as long as you put them in the correct order. Alright, let's go ahead and show you a couple more ways to create a series before we actually start working with data in a series. Another quick way to create a series is by saying pd.series, and you can pass any NumPy array. And this is going to work exactly the same as a Python list. So here I passed in the NumPy array, and it worked the same way. And just like the list, I could have also passed in labels along with this NumPy array. So essentially a NumPy
it's easier. Oh, where do you mean the array? Oh yeah, we did.
Array is going to work the same thing as a Python list as far as passing it into a series. And then finally, what's really cool is you can say PD series and just pass in a dictionary. And what Pandas is going to do is it's going to automatically take the keys of that dictionary. Let me just go ahead and show it here again. Take the keys of that dictionary, set it as an index, and then set the value of that key to the corresponding data point. So that's a nice fast way to quickly create a series. All right, something to note here, and another thing that differentiates a NumPy array from a Pandas series is that a Pandas series can actually hold a variety of object types. Right now, we've shown a Pandas series, pd.series, holding just numbers. So for instance, I've shown it holding just an array of numbers, but it could have also hold as the data labels itself, which remember is labels, if I go ahead and run this here, is just strings. So a series can actually hold pretty much almost any type of data object with Python as its data point. So it can be strings, and even more interesting than that, I could say data equals, and you could have actually passed in built-in functions. So I could say something like sum, print, len, and it's actually holding references to these built-in functions as data points in this Pandas series. And that's not something you can do with a NumPy array. Now, you'll probably never actually use this as far as posting functions or references to functions in a Pandas series, but this is just to demonstrate the flexibility of a Pandas series as far as holding different object types. All right, let's go ahead and move on to actually using an index. The key to using a series is understanding its index, and Pandas makes use of these index names or numbers by allowing for very fast lookups of information, and it works just like a hash table or a dictionary. Let's go ahead and see some examples of how we can grab information from a series. In order to do this, I'm going to create two series. I'm going to make one called ser1 and say pd.series. I'm going to pass in some data. We'll go ahead and say 1, 2, 3, 4, so just a list for my data. And then for the index, I'm going to go ahead and put in some country names, such as USA. We'll put in Germany. We'll put in USSR. And then Japan. So these are kind of like World War II country name references with some values. So I'm going to check out series 1, ser1. And here I have my series. Notice now I have index labels, and 1, 2, 3, 4 are my data points. And note it'll say dtype integer 64 since my actual data points are all integers. Then I'm going to make series 2 in a very similar fashion. I'll say pd.series 1, 2, let's say 5, 4. And then for the index, I'll go ahead and say USA, Germany, and I'm going to on purpose change one of these. We'll say Italy as another World War II country, and then we'll say Japan. And then if I check out series 2, I get 1, 2, 5, 4. So Italy's a little different here, and it has a different data point. Now, if I actually want to grab information out of the series, it's going to work very similar to grabbing information out of a Python dictionary. Type in the series, and then as a string, you can go ahead and type in the actual index label, USA. Now, keep in mind, I'm typing this as a string because I know that the index is a string. If I'm working with a series, such as up here, that has 0, 1, or 2, you would just pass in an integer. It depends on what data type is your actual index. All right. Usually your index is going to be hopefully either a number or a string, so you can either pass in ser1 and then the string, or ser1 and whatever your integer index is. So for example, if I quickly create another series, such as ser3, we'll go ahead and say pd.series, and we'll just pass in the data as labels. If I check ser3, now I have a, b, c as my data points. Dtype is an object, which kind of refers to the fact that it's a string, and I can grab stuff out of this by the integer index, versus the fact go ahead and say pd.series, and we'll just pass in the data as labels. If I check ser3, now I have a, b, c as my data points. Dtype is an object, which kind of refers to the fact that it's a string, and I can grab stuff out of this by the integer index, which is kind of typically how you would do this for a NumPy array. And then there's the string a returned to me. So you just pass in the actual index label, and it'll return the data that corresponds to that index label. As far as very basic operations to do with a series, they're usually done based off the index. Meaning if I were to say something like ser1, and then we have SER2, and let's say I try to add this, so I say SER1 plus SER2. What's going to happen is it's going to try to match up the operation based off the index. So it's going to say USA is 1 here, and USA is 1 here. So it'll add them up and say, as a result, USA will be equal to 2. Where it cannot find a match, such as Italy, it will put a null. And then USSR is also not in both of them, so it's going to also put a NaN object there. Let's go ahead and see what happens when we run this. And there we see the results. So USA was 2.0, Japan was 8.0, Germany was 4.0, and then where it didn't find a match, it went ahead and put in a null value. Something to note here is that when you're performing operations with a pandas series, and really pretty much almost any NumPy or pandas-based object, your integers are going to be converted into floats. And that's so you don't accidentally lose information based off of some weird division. And that has to do more with Python 2 and the fact that true division versus classic division is actually differentiated in that older version. If you're using Python 3, you basically don't have to worry about this, but you just have to keep in mind that pandas and NumPy will always convert stuff to float in order to retain all the information possible. Okay, we'll go ahead and stop here for now and move on to data frames, which can expand a lot more on the concept of series. In order to fully understand data frames, you just need to know the basics of series, which is just that they have a labeled index and then a data point. Really, throughout this course, we're not going to be working too much with series. We're going to be working a lot more with data frames, which is the true workhorse of pandas. Let's go ahead and jump to the next lecture where we'll talk in a lot more detail about pandas.
For sure. All right. Next one. Let's go ahead and blast through it, man. This entire thing is an hour and 43 minutes. Pandas exercise is the next thing. Ooh, I can do it in less time. I could watch the videos in less time. It's probably gonna take me the same amount of time, factoring in the fact that I'm gonna be writing or typing down some of these examples as he's doing it. But tomorrow we can get into Matplotlib. So we can actually get to the machine learning meat, pause, by in 8 days at the very max. But I'm looking at 10, 11, and 12. 7 and 8 can be done the same day. 9 is going to take a whole day to do. 10, 11, and 12 can be done the same day. So it's 1, 2, 3, 4. We can knock this thing down by Friday. All right, let's keep pushing through.
Hello everyone, and welcome to the data frames lecture. In this lecture, we're going to finally learn about data frames building off of the series object. Data frames is going to be their main tool when working with pandas. Let's go ahead and jump to the Jupyter Notebook to see how it all works. All right, here I am at the Jupyter Notebook. I'm going to go ahead and say import numpy as np and import pandas as pd. And I'm going to do one last thing here. I'm going to say from numpy.random import randn. And then I'm going to go ahead and set a seed. And what a seed means is just to make sure that we get the same random numbers. That way, if you're following me, you'll see the same random numbers that I see. So you can go ahead and say np.random.seed. All right, let's go ahead and explore the data frame command. I'm going to say df is equal to pd.dataframe, and you can actually use tab here if you're using Jupyter Notebook to autocomplete this. And notice that the f is capitalized. I'm going to do shift tab to check out the doc string and the initial signature for this pd data frame. We have a data argument and an index argument, just like we did for series, but then we have this additional columns data frame. a data argument and an index argument, just like we did for series, but then we have this additional columns argument. Let's go ahead and build this up with some random data, and we'll see what a data frame actually looks like. First thing I'm going to do is pass in that data argument, and I'm actually just going to call rand n 5, 4. And then the next ones we want to pass is the index. And the index, we can just make that a list of characters here. I'm going to go ahead and say A, B, C, D, E. And then finally, for the columns, I'm going to go ahead and say W, X, Y, Z. So I'll say W, X,
I'm going to watch this example
Y,
first.
Z. I'm going to go ahead and run this, and then pass in the data frame just to display it. And there we get a nice display, and this probably looks and feels a lot like Excel if you're using a Jupyter Notebook, and that's good. If you're using another IDE editor, you may not get such a nice crisp display, but you should get a printed output that looks similar to this. Alright, so basically what we have here is a list of columns, W, X, Y, Z, and corresponding rows, A, B, C, D, E. Now, each of these columns is actually just a pandas series. So W is a pandas series, as well as X, Y, and Z. And they all share a common index. And that's basically all data frame is. It's just a bunch of series that share an index. Let's go ahead and show how we can use indexing and selection to actually grab one of these series objects, or several of these columns out. One way, and the main way to do this, is by saying df, and then using bracket.
Okay. I'm going to go for it.
Notation, and then passing in the column name. In this case, let's go ahead and grab the W column. So as a string, I'll pass in W, and this returns the W column. And now take a look at the output. Now this actually looks like a series, and that's because that's exactly what W column is. It's just a series. And you can actually confirm this by saying type of df of W, and it shows that it's pandas.core.series.series. If I just say type on the df object itself, I will get a data frame out. So again, just to reiterate that fact, that a data frame is just a bunch of series that share the same index. Now, there's two different ways you can grab a column from a data frame. The main way, and the way you should always do it, is using this sort of bracket notation and then passing the column name. However, if you're really familiar with SQL, a lot of times when you're selecting a column, you pass in a table, dot, and then the column name. This actually also works for pandas. You could say dot and then the column name. However, I would recommend that you don't use this because it may get confused with the various methods that are from the data frame. For instance, if I say df dot and then click tab, I see a whole bunch of methods available for me. And those are a bunch of methods that we're going to learn about as we learn more about pandas. But what may happen is that one of these methods gets overwritten by a column name, and then pandas is going to get confused whether you're asking for a method or an actual column name. So what you should do to avoid that is always use this sort of bracket notation when requesting a column. Okay, if you want multiple columns back, then you can go ahead and pass in a list of columns. So note that I pass in my brackets, and then I'm going to pass in a list of column names, which is going to result in another set of brackets here. For instance, if I wanted columns W and Z, I pass in a list, here highlighted, W and Z, and I get back a data frame containing those two series. And that means when I ask for multiple columns, I'm actually getting back a data frame. If I ask for just a single column, then I will get back a series. And in the Jupyter Notebook system, that's denoted by the way the output is displayed. Okay, let's go ahead and move on to creating a new column. Pandas supports creation of new columns by just specifying the column as if it already exists. For instance, new. Now if I run this, I'll get an error, and it's a key error. If you scroll all the way down here, it'll say key error, new, And it basically just is trying to tell you that it can't find it, that there is no key in U there. However, when you're creating let me go ahead and hashtag that out and put this back in. When you're creating a new column, you can actually define it as if it already exists, and then on the right-hand side of this equal sign, use other columns with arithmetic in order to pull off a new column. For instance, we can say df new column as if it already exists is equal to dfw plus dfy, and this will run with no error. And now if I check out df, that new column is actually in place there.
No kidding.
And for removing columns, you can
name this one Z2. Shake it up a little bit, be a little different. Change up the values too. Actually, no. I'm gonna do Z times 2. See what happens. A little bit of arithmetic. Cool.
You can say df.drop. You can say df.drop and pass in the actual column name you want to drop. Now, if you just do this by itself, you'll get an error. And let's go ahead and check out what that error is. It'll say value error, and if we scroll down, it says labels new, not contained in access. And if I click Shift Tab on the drop method, notice that by default it says access is equal to 0. Access equal to 0 for the drop method refers to the index. If I actually want to refer to the columns, I need to specify access is equal to 1. And then it will drop that new column here. Now there's two things to note when using this df.drop. The first thing to note is that this doesn't happen to drop the index. If I actually want to refer to the columns, I need to specify access is equal to 1. And then it will drop that new column here. Now,
how's access?
And if I click Shift Tab on the drop method, notice that by default it says access is equal to 0.
Right.
Access equal to 0 for the drop method refers to the index. If I actually want to refer to the columns, I need to specify access is equal to 1.
Got it.
And then it will drop that new column here. Now there's two things to note when using this df.drop. The first thing to note is that this doesn't happen in place, meaning I'm not actually affecting this data frame unless I specifically specify this to occur in place. I'm going to go ahead and show you what I mean by that. I've called this line df.drop new access equal to 1. If I call df, I'll see that I still have that new column. That means I need to actually specify as an argument, and we'll do Shift Tab to show it, the in-place argument. And many Pandas methods will require this in-place argument to actually specify drop new access equal to 1. If I call df, specify in place, meaning I'm not actually affecting this data frame unless I specifically specify this to occur in place. I'm going to go ahead and show you what I mean by that. I've called this line df.drop new access equal to 1. If I call df, I'll see that I still have that new column. That means I need to actually specify as an argument, and we'll do Shift Tab to show it, the in-place argument. And many Pandas methods will require this in-place argument to be set to true. And the reason Pandas does that is that for you not to accidentally lose information. In case you've done a bunch of adjustments to your data, you don't want to accidentally lose it. So Pandas requires you to say in-place equals true if you actually want a lot of these changes to stay and occur in place. And now if I call df by running this cell, notice that new column is now permanently removed because it occurred in place. And something to note here is that we can also use df.drop to drop rows. For instance, let's go ahead and use this to drop the E row. I'll say df.drop, I pass in E, and I can also say access is equal to 0. Now remember, you actually don't have to add that in as an argument. That's the default.
It's default.
So let's go ahead and just say df.drop E, and there we've been able to drop the E, since access is equal to 0. And it works either way. I could say access is equal to 0, and this will work again. And note here, I'm not doing this in place. Okay, sometimes a point of confusion is why are the rows 0 as far as their access, and why are the columns 1? Well, the reference actually comes back to NumPy, since data frames are essentially just fancy index markers on top of a NumPy array. To show this, I can say df.shape, just like we did with a NumPy matrix. And note, df.shape is a tuple for a two-dimensional matrix here, and at the 0 index are the number of rows. So if I say df here, I have 5 rows, A, B, C, and D, E. And then on the index 1, I have 4 columns, W, X, Y, Z. which is why rows are referred to as the 0 axis and columns are referred to as the 1 axis, because it's directly taken from the shape, just as you would with a NumPy array. Okay, now let's talk about selecting rows. We've talked about selecting columns, which you just do by saying df, and in brackets, you pass in the column name. Or, if you want many columns, you pass in a list of the column names, such as z and then comma x. Let me close off that bracket. So I'm passing a list of column names, and I return a data frame of those multiple columns. Let's talk about selecting rows. I'm going to close off that bracket. So I'm passing a list of z and then comma x. Let me close off that bracket. So I'm passing a list of column names.
Makes sense. That's straightforward.
And I return a data frame of those multiple columns. Let's talk about selecting rows. I'm going to take a look at my data frame again. Here's my data frame. A, B, C, D, E is my rows. W, X, Y, Z are the columns. There's two ways to select rows in a data frame. And you have to call a method off of this. And there's two methods to use. One is loc, L-O-C, for location. And this is going to take in a label. So you can also do Shift-Tab here to see this property. And something to note here is I'm using square brackets, which is a little weird, but that's the way it works with pandas. You pass in .loc, and then you pass in brackets the row you want. For instance, if I wanted the A row, I just pass in .loc, and I pass in the label of that index. And this returns, note, a series. And this comes to our second conclusion, that not only are all the columns series, but the rows are series as well, as far as the way they're going to get returned when you request them in pandas. Now let's discuss the second way to grab a row, which is based off of index position. I can use df.iloc. Actually pass in a numerical index position even if my axes are labeled by strings. For instance, if I want C, that row, I can do that two ways. I could either say df.loc for location.
Let's do it real quick. df.loc, excuse me. Cool.
And in brackets, pass in the row name, which is C, or I can say iloc, which is index-based location, and count what index it's at, so 0, 1, 2, and then on iloc, pass in 2, and this also returns that row. And that basically means you have two ways of selecting rows, using loc if you want the location or label-based index, or iloc if you want the numerical-based index. Okay, let's talk about selecting subsets of rows and columns. And this will actually be very familiar to you since we've just learned about NumPy. We can say df.loc. If we want to select a subset of rows and columns, we can pass in, just like we did with NumPy, using comma notation, the row we want and then the column we want. So I want the value at row B, column Y. And this returns just a single value there. So if I take a look at my df again, looking at row
direct.
B, column Y, I have this negative 0.84. I get the same result here. So just like NumPy, you can use this row, comma, column
just because
notation.
I know what it is already.
And if you want a subset of this, you can say df.loc and then pass in a list separated by commas. For instance, let's say I wanted the subset of A, B rows with the WY columns. So basically I wanted this 2.7, 0.9, and 0.65, and negative 0.84. That means I can just pass in a list of the rows I want, which in this case is A and B. And then I can pass in a list of the columns I want. In this case, that's W and Y. Shift enter that, and I get this subset return of the data frame. Okay,
nice.
We're going to stop it here for now and continue this discussion in part 2 of the data frames lecture. And this is all in the notebook called Data Frames under the Pandas folder. Let's get a quick review of what we've learned. As far as creating a data frame, you just need to say pd.dataframe, pass in your data, pass in your index, and then pass in your column names. Usually we won't be building data frames by hand in this manner. We'll actually be reading data from some sort of source, like a CSV file, but we'll learn how to do data input and output later. For now, if you want to manually create a data frame, that's how you can do it. Then, for selecting columns from a data frame, you can say df, and then in brackets, pass in the column you want, or...
Got it.
We're going to look at conditional select...
Didn't give me the credit for it. Hold on.
Or pass in a list of the columns you want. Remember that each column is actually just a series. You can create new columns based off of old columns by using this sort of arithmetic. Then you can drop columns or rows using df.drop. Remember, you'll need to say in place equals true if you want the effect to be permanent. You say axis 1 for columns, and then axis 0 for rows. And again, that comes from this shape tuple. 0 index was rows, 1 index was columns. As far as selecting rows from a data frame, there's two methods here. There's the .loc method, which is a label-based index location, or there's the .iloc, which is the integer-based index location. And then if you want to select subsets of the data frame, you can use .loc and pass in either values or complete lists to return subsets of the data frame. Okay, that's it for the very basics of data frames. Coming up next, we're going to discuss even more of what you can do with Pandas data frame, such as using conditional selection. Alright, thanks everyone, and I'll see you in the next lecture. Conditional selection, as well as some multi-index parts of a data frame. Let's go ahead and jump to Jupyter Notebook to get started. Alright, here we are back at the Jupyter Notebook. I'm going to be using the same data frame as
why is it so low now?
last time. So remember, we just had to say numpy as np, Pandas pd, import rand n, set c to 101, and then say the data frame was rand n 5, 4. And then here we have our data frame. Okay, let's go ahead and talk. Talk about conditional selection. A very important feature of Pandas is the ability to perform conditional selection using bracket notation, and these are going to be very similar to NumPy. For instance, if I use a comparison operator against the data frame, such as asking where's the data frame greater than 0, I will get a data frame back of Boolean values, where it returns true if the data frame value at that point was greater than 0, and false if it was not greater than 0. And this is very similar to the same conditional selection applied to an entire NumPy array, except in this case we're doing it with Pandas data frames. And just like this, we can go ahead and say bool df is equal to df greater than 0, and then say bool df, go ahead and check that out. And here we have our Boolean data frame, and if we pass that in to our original data frame with bracket notation, then we'll get out, as a result, values where it was true, and nulls, or NaN, where it happened to be false. And that's the way you can use conditional selection along with a data frame. Now, usually you probably wouldn't be separating this out into two steps. You would just say df, and then in brackets, something like df greater than 0, and you would get this result. This sort of operation with a data frame and against a comparison operator isn't that common. What most likely you'll end up doing is instead of just passing in the entire data frame, you'll pass in a row or a column value. And instead of returning nulls, what that's going to do is return only the rows or columns of the subset of the data frame where your conditions are true. Now let me go ahead and show you an example.
Slow this down.
Of the subset of the data going to do is return only the rows or columns of the subset of the data frame where your conditions are true. Now let me go ahead and show you an example of what I mean by that. Let's go ahead and take a look at our original data frame. Here we have rows A through E and columns W through Z. What I'm going to go ahead and do is specify df of W greater than 0. And notice I get a series back. True, true, false, true, true. And this is linked to the actual index. And if I take a look at the W column, I see that this corresponds with the W column values. And the value at index C was actually less than 0, so it returns false for being greater than 0. I can now use this series of Boolean values corresponding to rows to filter out rows based off of a column's value. And that means if I pass in this series into a data frame using bracket notation to say something like df of dfw greater than 0, I will only get back the rows where this happens to be true, meaning I'll only get back the rows A, B, D, and E. It won't return row C since it was false here. Let's go ahead and run that and see what this looks like. Great. And now, since I'm passing in a series, I don't get those null values anymore. You only get those null values when you're doing this sort of condition on an entire data frame. When you're actually passing in conditions based off of columns, you'll just get series values, meaning you'll get only the rows where it happens to be true. And this is the sort of conditional selection we're going to be using most often throughout this course. Let's go ahead and show just a few more examples to really drive this point home. Let's say I want to grab all the rows in my data frame where Z is less than 0. So I say df, where df of column Z is less than 0. Now let's take a look before we actually run this, what should happen. Well, we'll notice column Z, where is it less than 0? Well, that's only occurring in row C. So column Z, as in Zelda, and then row C as in cat. Here, this is the only row that should be returned. But remember, we're asking for the entire data frame back, so it should return just this row C for us. And there it is. Okay, great. Now something else to note here.
Yeah, just C. Yeah.
Is that when you're doing these sort of commands, let's go ahead and go back to our W greater than 0, you get a data frame in response. And that means you can go ahead and call commands off of this data frame. Then you can do this either in one step or two steps. I'm going to go ahead and say result df is equal to this, and then take a look at result df, which is the subset of the data frame without that row C in it. That means I can go ahead and grab results off of this, such as X. I'm going to go ahead and say result df is equal to this, and then take a look at result df, which is the subset of the data frame without that row C in it. And that means I can go ahead and grab results off of this, such as X. And here I have 4 values of X, A, B, D, and E, based off of this resulting data frame that didn't have that row C in it, as in Charlie. But instead of actually separating this out into 2 steps, such as grabbing the X column, I can do this all in one step. And let me show you what I mean by that. I can go ahead and say, return the data frame where the column value of W happens to be greater than 0. So return those rows to me. And that means all the rows minus the C row. And since this is a data frame, I can actually go ahead and stack commands such as bracket notation on top of it, such as return the X column where that's true. And now I get the same results as I did up here, except it's all done in one step. And this is something that can be intimidating to beginners at first, since there's a lot of brackets and a lot of stuff going on here. But essentially, this is just, instead of splitting everything up into multiple steps, I'm putting it all into one step. And likewise, since this is a data frame, I can bracket for multiple columns by passing in a list, such as y comma x. And we can see we get a result here. Let me go ahead and break this line down one more time to show the steps that we're taking. First off, we're going to go ahead and say bool df is equal to, well, let's go ahead and say bool series, since that's a little more accurate, is where dfw is greater than 0. So if I say bool series, I get this Boolean series back. Then what I'm going to go ahead and do is say result is equal to df of that bool series. Let's go ahead and check out the result. And it should just be wherever that series was true, which is A, B, D, and E. And there is my result. That's the entire data frame without the rows C in it. And then I can go ahead and off of that result, call a list of columns. So we can go ahead and say y comma x. And if we wanted to, we could actually even separate this out into one more step by saying my calls for columns, pass in that list, and then say result of my calls. And we get the exact same thing we have here done in one line as in multiple line. Then what I'm going to go ahead and do is say result is equal to df of that bool series. Let's go ahead and check out the result. And it should just be wherever that series was true, which is A, B, D, and E. And there is my result. That's the entire data frame without the rows C in it. And then I can go ahead and off of that result, call a list of columns. So we can go ahead B, D, and E. Series W is greater than 0. So if I say bool series, I get this Boolean series back. Then what I'm going to go ahead and do is say result is equal to df of that bool series. Let's go ahead and check out the result. And it should just be wherever that series was true, which is A, B, D, and E. And there is my result. That's the entire data frame without the rows C in it. And then I can go ahead and off of that result, call a list of columns. So we can go ahead and say y comma x. And if we wanted to, we could actually even separate this out into one more step by saying my calls for columns, pass in that list, and then say result of my calls. And we get the exact same thing we have here done in one line as in multiple lines. That means if you're ever confused on something that looks like this with a ton of brackets and pandas, see if you can break it down into multiple steps if that makes more sense to you. Throughout the course, we're going to be doing this type of notation, these kind of one-liners, and as you get more and more comfortable with pandas, you'll find yourself using these one-liners more and more often. But if you're ever confused, always feel free to break it down into multiple steps. The only disadvantage as far as breaking it down to multiple steps is that you are taking up memory with each variable that you define. So as you get better and better with pandas, you'll want to move towards this simple one-line abstraction of all these commands. All right. Go ahead and pause the video now and really make sure you understand how line in 58 here is the exact same thing as separating it out into multiple lines. All right, let's go ahead and explore real quick the...
Dang. It's not even hard, it's just time consuming. My energy levels are low. Yeah, I'm gonna seriously start doing this during the day. Well, I guess tomorrow during the day. That's my only day. We'll see what happens. I'd have to end this one short. Let's do an experiment. We're gonna come back tomorrow. We're gonna go to sleep now. Come back tomorrow. See how much more efficient we are after we sleep. Yeah. I like that idea. Let's see what happens. Oh yeah, good session. We started off strong. We got in there. Keeping pace, keeping momentum. Each and every day, as long as you just do some, even if it's like 20 or 30 minutes, it's progress, right? Okay.